All right. Good morning, everyone, and thank you for joining us on today's Fusion 360 webinar brought to you by KETIV Technologies. My name is Brian Mulkopensik, Customer Success Manager here at KETIV, and this is Autodesk Virtual Academy. And today we'll be, of course, talking about large assemblies and large renderings inside of Fusion, more specifically, how to import them into Fusion for whatever use case scenario. Today we'll be addressing rendering, of course. So if you have any questions or comments, definitely leave that in the Zoom chat window, and I am happy to help answer those. I'll try to save them for the end just so we can get through the content as much as possible. So the word of the day is going to be conundrum. What conundrum are we trying to get past? What problem are we trying to solve? So here's the situation. We have a large assembly in a third-party CAD software, whether it's Inventor, whether it's SolidWorks, and we want it to be rendered for sales or marketing purposes. We want to have it printed on a large poster board. We want to have it be sent to a customer to see if they want this to be manufactured. And we're using this example, this buffer skid, that's actually an Inventor sample. If you do a Google search for Inventor samples, this is in the 2016, 17, 18 Inventor samples in the zip files. You can grab and use this yourself. This I would say is a relatively large assembly because of all the little sub-assemblies here you see on the side, and there's more parts inside of that. So we're going to be using that as our example today. And some typical issues customers run into and have been running into, which is the reason for this webinar in the first place, is because they aren't getting the high enough quality renderings inside of their current software, or their local hardware is not powerful enough to create those high quality renderings. So they're looking elsewhere for that. Another issue is renderings might be taking too long. So high quality renderings may take up multiple hours, tying up your engineers or your designers' time. And the question I have for you is, how much time are you worth per hour? So if you're watching a computer screen for half of the day for a rendering to finish, and your computer is essentially tied up completely trying to run that, how, is that worth your time? Or is it better to outsource that to the cloud, which is what Fusion is capable of? And the other thing is renderings might come out too small. And this might be more of a settings thing. But if you're trying to create some large renderings and your previous software isn't able to do that, you might be able to get away with, or you might just need to go look at the settings, and maybe it's just a lack of knowledge of how to use it. But Fusion can create somewhat large renderings. If you want extremely large renderings, you want to look at software like 3ds Max. If you want relatively large, Fusion can probably get you what you need. All right, so let's consider Fusion 360, because we can create high quality renderings. It's been proven time and time again. If you look on the Autodesk gallery, there's a lot of renderings, not only for Fusion, but other software as well. Like I think Revit has a lot of architectural renderings on there, but Fusion has some like this. So you can definitely produce these high quality renderings. One of the main reasons you'd want to use Fusion's rendering is because you can outsource it to the cloud. This offloads your local computer resources. And since Fusion is cloud enabled, you can have it tax the cloud rather than tax the RAM on your current machine. And going back to the size of the rendering, you can do 4,000 by 4,000 pixels inside of Fusion, which is equivalent to, like, if you're printed out on a poster board, roughly 2 feet by 2 feet. So anything larger than that, again, I would look at other software, but this is good enough for that. And it's usually that's what people are looking for. So I'll show you where we can adjust those settings today. And just some other tools worth mentioning that for reasons for you to come over to Fusion with a large assembly, or just in general, is to use it for generative design, which is also utilizing the cloud. CAM extensions, manufacturing extensions, which is different than Inventor CAM because you're able to they put more CAM tools inside of Fusion and more advanced ones as well. So that's hugely growing. They've recently updated the mesh environment to be able to manipulate mesh, which is actually the topic of our next month's class, which is going to, or webinar, which is going to be on mesh editing. If you've seen the one by Autodesk, Jason Lickman, he did a really great live feed on that on I think it was YouTube. And then lastly, Eagle PCB board integration. So for any electrical users, they have pushed Eagle into Fusion, integrated them. So a lot of electrical users have come into using Fusion as well, and they have a integrated workflow between the two, which is really nice. So everything is coming into Fusion. Autodesk is pushing everything to Fusion. So let's go ahead and get on into it. First off, when you're bringing large assemblies into Fusion, you need to consider, okay, if I'm trying to render this sofa, do I need to bring in this entire house, if you will? Just make sure you're bringing in the parts that are necessary. You don't bring in the whole thing. If you're bringing in a sofa, are you going to bring in, little nuts and bolts under the covers of the sofa? Do you need to show, or do you need to import things that aren't even visible? So just right off the bat, you can lighten the load of what needs to be imported into Fusion. And I'm going to go into Fusion after the slide here, but we have a couple of places to start. One, you can consider, and these are options, and I'm going to highlight the ones that I recommend. The first one is like thinking, okay, I have Inventor and Fusion on the same machine. Can I just tell Fusion to look at the IAM file? And let's go ahead and pull up Fusion and test that theory. So if we go here to our data panel, let me create a new folder called test2. And in this folder, I will upload that large assembly. We'll just go to upload, select files. And this large assembly is this IAM here. And if you may know, Fusion's not going to like that because it's only an IAM file. It doesn't understand it doesn't have a project file to reference. It doesn't understand how project files work. So it's going to need the IAM file, the top level assembly, along with its other components. So what you can do is you can go to select files and find those other components, which are here. These are the other components. But if you hit enter here to select those, it doesn't like the folder selection. So it just references me to, okay, please select actual parts and assemblies, Brian, not just the folders. So one way to go around that actually is if you pull up a file explorer and just hold shift select and just drag and drop it that way instead. It's going to be happier with that. It might take a while. It might take like 30 seconds, 20 seconds here. But once it detects those files, and I think it just hit it behind the screen there. Once it detects those files like this, now you're able to drag with just the folders and not necessarily the files themselves. So that was like a little workaround, I would say. But now that you have this, let's go ahead and hit upload. And there's pros and cons to this. Pros is you have the files you need because you just selected everything essentially. Cons is you brought in files that might not even be associated with this assembly file, and you might not know if, like, let's say you didn't know that all the files were located in these folders. Maybe there's one in a different folder altogether and you forgot about that. So just keep that in mind. I don't recommend this way just because there's chance for errors. And while this is loading, I'll show you the way I do recommend. One of the ways that I recommend is using a save as and pack and go. And there's pack and go in SolidWorks, there's pack and go in Inventor. So I'm partially assuming that you can use a similar format for the other softwares. But in Inventor, I'll show you right now, you are able to consolidate or just condense all of your used and needed files in this assembly to said pack and go folder. And the benefit to this is not only do you get all the files you need, but you're also getting the bitmaps. So like the images, the little textures of your model. You're getting the color and you're getting the components. So if we go back to Fusion here, let's go ahead and close that. And let me put a new folder in here. This will be the pack and go example. And I'm going to hit upload. Let's go to, or no, sorry, we need to do the pack and go first. Let's go to Inventor. Here's our model. Again, if I were to kind of take a look at this first, I would hide anything that's not showing. So maybe like, or that won't be showing in my rendering, or I don't plan to. So maybe like some of the files or some of the parts back below here or behind here, which there's not much I could take away from this without taking away from the actual rendering itself. So I'll just leave it at that. But now let's go ahead and do the pack and go. So it would be under File, Save As, Pack and Go. Looks like there's some edits I need to do. So let me just hit OK there. And it's on the other screen. I'm just hitting OK on another screen to make some edits. Okay. So here is the standard pack and go window. It's telling me where do I want to put this pack and go. Let's go ahead and create a new folder. Not in there. Let's put it in, or let me just call it large assembly test 2, since I already have a 1. And let's drag this out. Let's put it in. Let's put it under Brian's files, actually. There we go. Large assembly test 2. Okay. All right, we're going to pack and go to that location. We are going to keep the folder hierarchy just for this example. And we're going to include any linked files. We'll go ahead and search for those. And it's finding 224 files for us that we can see all of them down below here. And if there's anything you want to disclude, you can go ahead and uncheck that here. Definitely not that one. But then we will go ahead and hit start. So it's going to go ahead and pack and go it to that location. It's not going to exit out of this window. We just hit done when it's done, and it is done. And now, if we go back to Fusion, we go to our upload, we can find, and I think I saved it in C, Brian's files, largest assemb. I didn't finish the LY there, test 2. We can find the under workspaces, tube and pipe. And there it is right there. And same thing. If we click on this, it's going to ask for the rest of the folders. So we're going to go through our workaround methodology of going to the File Explorer and finding it that way by dragging and dropping these folders. And these, we know for sure, are going to be utilized inside of this assembly file. So we're going to go ahead and drag and drop that in. It's going to we'll go ahead and give it a minute because there's a lot of files here, and we'll hit upload. So while that is uploading here, and you can always see by this upload process. So if I close this and you're like, oh, where's the status of it? You can always go to the data panel. We just open this data panel. Bottom left here, you can see the status of all your jobs. So if we go back to our test 2, we can see that the previous one, the one where we went straight to the model and import it, it is here, which is great. It did give us an error report. And let me just go ahead and open this one. This is more of a personal issue with this model. So if you have an assembly file, you might not get this. But this is just telling me some of the files that I was referencing. There were like some standard parts, so don't worry about that. But I did get all the files that I needed to, as you can see from the preview here. But it does bring up in some extra baggage, which is why I don't recommend this way. But it does bring in what you're looking for. It's just there are better ways, such as the pack and go, which I'm showing. So this is one way. Let's go to the pack and go example. And I'll let that load. And in the meantime, while that loads, let's go look at our third option, which is exporting as a step file. So this actually makes a much lighter model for you to bring into Fusion. So if your assembly is very large and it's lagging way too much when importing into Fusion, consider exporting as a step file, making sure all your files are visible when doing so, because if they're not, the step file won't show it. And you will lose bitmaps though when you do it as a step file. If that's important to you, then that's not an option for you. But if you don't care about the bitmaps, and I'll show you what those are, then you can use the step file. So this one just finished, which is great, awesome. It has another error report, but there it is right there. So let me export as a step file, and then we'll come back to this. So let's go to Inventor, File, Export, and then CAD format. And let's export as a step file. I already have one here, so let me call this one AVA example, and there'll be .stp. And this will be saved at that location there. So it's going to export this as a step file, and I'll show the file size comparison. So we take a look at this. We take a look at this large assembly test pack and go, where I click properties. It's about 122 megabytes. And if we take a look at that step file, I wonder if it's done yet, that we just exported out. Models, tube and pipe, buff skid. There it is right there. Properties, 20 megs. So it's pretty different to say the least. And if we go ahead and import that, let's create a new folder for that. Step file example. Oops. Upload. Let's see, Autodesk samples, models, tube and pipe, and the AVA example step file. It'll upload a lot faster as well. We can actually watch this one, but I won't actually watch it because we got things to show here. So let's go back to our pack and go example, and let's take a look at that. So it's going to look essentially pretty much the same thing as the previous one, except with this one, it's just lighter. So that's why I recommend using a pack and go when exporting large files. And as you can see, my Fusion is handling this pretty well. I know other users that might not have as powerful as a machine or a graphics card might not be able to handle something larger in Fusion. So I'd be lying if I was saying like, oh, Fusion can run on any machine, like as strong as it can on this machine, because some machines just perform a little bit better, and you're less prone to crashing and things like that. But I am able to move this large assembly pretty fast. And a quick little tip to seeing, okay, how many components are in here? How many am I actually running inside of Fusion right now? And let me pull up the PowerPoint. SAT is next here. But there is a file view show text commands option, which gives you the ability to see the number of components in your Fusion. So if you go over here to file, view, show text command, and this is something I newly learned. You have this little window down below here. And if you type in this box, it was components dot counts, enter. No command. Oh, components is not plural, sorry. Component dot counts. The leaf occurrences are our components. So there are exactly 900 components, and there are 911 bodies in here. So that's how you can find out through some text commands how many components and bodies are in this file, which is pretty neat. I don't know what use case scenario, but I mean, if you need to know, if you want to know how powerful or how many components you're running inside of Fusion, there you go. You can use text commands there. All right, so going back to I was skipping ahead here. Let me go back to this. So we had the pack and go option, which I recommend. I also recommend the step file option just to make it lighter. And if we open up Fusion, here's the pack and go, right? If we take a look at the stairs here, here's the bitmap I'm talking about. Here's the picture image of these cross parts of the metal that makes it easier to non-slip, right? So if we have something like that from the pack and go, and then we go ahead and take a look at our step file example. So yeah, it's lighter for a reason. Sorry, let me open that up. So if we take a look at the same stairs, like we have everything else come in fine, which is good. We took a look at the same stairs. Bye-bye to the bitmap. So if that's important to you, if you really want to show the bitmaps on the stairs, then don't do step files again. Also, notice how, if I go back to our pack and go, there is a hidden file. And I didn't talk about this yet, but there has been all along this hidden buffer room that kind of encompasses the entire model. If we go back to our assembly file here, the step file here, this doesn't have that. That's because I didn't show that when I exported that over to Fusion. So keep that in mind when you are exporting with a step file inside of from Inventor to Fusion is to show your buffer room. So if I were to do that step file over again, I'd go back here, right click, and toggle the visibility on, and then I would export that again. All right. And then another option, I just played around with one other option, was the SAT file format, just because I heard of people using that. And this option, I didn't highlight because I don't think it's useful, because you lose your bitmaps and the components in your browser history here. And I'm not even going to waste time uploading it. All these components here would just show as bodies if you were to upload it as an SAT or export it as an SAT file format. So step format or pack and go are the ones I recommend for importing or exporting large assemblies over to Fusion. All right. Let me know if you have any questions on that whatsoever, because now we're going to talk about the rendering in Fusion now that we have it inside Fusion. So like I said earlier, we can do a max pixel size of 4,000 by 4,000, or roughly 2 feet by 2 feet. If you want something larger, try 3ds Max. So Fusion cloud credits, it's usually, or it's not usually, but it's approximately 1 cloud credit per dollar. So if you want something as large as 4,000 by 4,000 pixels, that would be 16 cloud credits. If you want something tiny, it can go as low as 1 cloud credit to do a rendering, but that's probably not worth your time to make it something that small. So that's how much it costs. And just think about it this way. If you run a rendering that takes multiple hours, that's 4,000 by 4,000. Think about how much time that is compared to $16. Multiple hours of engineering designer time as compared to $16. Unless you, and I mean, you have the option to run it locally. It's not like you don't, but if you are working, if this is right in the middle of your work hours and you're trying to get a rendering done at the same time, you have the option for this outsourcing. And when you bring in Fusion, please don't turn on design history. That will bog it down for no reason, unless if you're trying to model something, just do that before you import it. And you can still model things in Fusion, but just you don't need to turn on the design history. You just bring it in there to render. And I already showed this, which is counting or putting in how many components or bodies you have in your model. And there's also some recommendations. If you are to run this locally, here's some hardware, not requirements, recommendations for trying to process some renderings. And this can be found if you do a Google search of Fusion 360 system requirements. It'll show at the bottom what is exactly this, what is recommended. All right, that was a little teaser of what we're going to do. So going back here into Fusion, we are going to work on our pack and go assembly here. So we can make some modifications to this. Let's go ahead and do this rendering first right off the bat. I don't have my design history on right now, so but this is blocking me, this pillar. So I can, without the design history turned on, I'm just going to extrude, just cut that away. Just want to get that out of the way of my shot here. Maybe a little bit more actually. Get out of here. Okay. And then the next thing I want to do, let's take a look. Let's just position the screen right. I do like to include this wall for at least this rendering. The next rendering, I won't have that wall. But it's nice to have walls we can apply textures to. And that will be a very that'll be very useful when we render, just from my experience, applying tech instead of just having a background that can have a faint texture. It's mostly like just blurred out in the background. Having actual physical 3D models in your renders look better. So let's just go ahead and just render this the way it is, and then we can edit it moving forward. So if we go to the design workspace to render, or from design to render, the nice thing about Fusion's rendering environment is that you have the ability to do some on the spot in canvas render, just to take a look at what it's going to look like before you actually send it out. So this is useful for saving your cloud credits, because if the lighting is off or the texture looks weird to you, then you can fix that up front rather than pay the 16 cloud credits and find out later, didn't really want it that way. So right now it's locally rendering. So this is just giving you a preview. You never really want to do an actual rendering in this environment here, but it is giving you a good preview of what it's going to look like. So for me, I personally think this should be more gray, more metallic looking. So that's something I might go in and change. But for the most part, it's pretty good. So we can go ahead and stop the rendering, and then we can go ahead and save that if we wanted to, or I can stop the rendering and actually add gray to that, which I will. So you can just stop it there. Not using any cloud credits or anything yet. And let me go here to our appearances. And let's see what appearances we can apply to this. Some dark gray powder coat. Just dragging and dropping some onto here. Emily actually drag and drop it onto everything here. Except the stairs. I don't want to get the stairs. Where are my stairs? Stair, handrails, stair. Let me click on the stairs, and then it should highlight it partially here. Oh, there it is. I didn't even reach that yet. Fabrication stairs assembly. Okay. So I'm going to highlight that again. all of this, holding shift and selecting, and then I'm going to hold control and deselect fabrication stairs. Press A for appearance on my keyboard, and then I will apply this powder coat to those, and I will remove all that just to give it a more maybe gray appearance. And let's drag and drop some of that onto there. And let's give the, actually no, we can leave the pillars as is. Let's do another in canvas render to give us an idea. Of what that will look like. And yeah, these, if you do renderings and working with large importations, you can see we're already 30 minutes in here. These take a long time because of just the largeness of the assembly and the size of, and then rendering in general takes longer than you may expect. It's not something where you can just design really quick and it's as quick as the designer. It's just the computer processing, calculating the ray tracing of the lighting that bounces off of the model. So this is something that I'm going to go with. So I'll go ahead and stop that, and we'll go ahead and I'll go ahead and show that how the rendering, we can just outsource it, which is really nice. And we can continue with our webinar here. So I'm going to put in the max custom length. I'll just show you here. If I put in 5,000, it's going to ask us, can you please put it in between 4,000, please? So I'm going to actually put 4,000. You can do that locally. Not going to, but we are going to run this and outsource this to the cloud, where in the position it is in now. So we'll go ahead and hit render on that. And I want, while it's rendering, while it's sent it to the cloud to be rendered, we're going to show one more option here, which is the ability to change the background, which not all CAD software has for rendering. So if I hide the walls here, oh, and this is a nice render too. So let me just do another rendering. Why not? I could just outsource that one to the cloud. I just like the looks of this here without the walls. So look, we're doing two powerful renderings at once, and it's not even taxing my machine, which is really nice. All right, now let's go ahead and import a scene settings, import an environment. So if I go here to replace custom environments to my downloads, you can bring in HDR or like 3D environments into your background here. And you can find some free ones online as well, or you can pay for some, like this. Sorry if I'm making you dizzy. Don't know what flag that is. Maybe someone can help me with that, with the geography. But you can also move the background's position. And this might not be the most ideal location for this, but I kind of like the ambiance of the gloomy day here. I'm getting a little dizzy myself. Sorry about that. Let me move this. Yeah, it might be floating in the water. Sometimes I like to just zoom in a lot just to get rid of the ground so people don't even see that it's floating on water. So it's all about what you're seeing here, right? So this can be a rendering spot here, and you might want to do a little research on how to best position your renderings. I know there's like a rule of thirds, or this is like a photo taking tip. It's like a rule of thirds. You kind of want to chop up your photo into thirds. Like this is 2/3 into my photo, or 1/3, and then this is 2/3 into my photo if you're looking from left to right. So it's kind of like more balancing to the eye. So we can go ahead and take a rendering of this. This would be our third rendering, and see how that looks. So yeah, I did a whole webinar where I dive into more details of rendering, but I'm just showing you some of the capabilities of what we can do with this large rendering And looks like the first or second one's about to be done very soon here in our rendering gallery. And these are job statuses. These don't show the rendering, but it looks like it'll just show in our gallery here. And then it could be downloaded right afterwards. So this one's done here. It looks like this was the one without the wall. I think there was less to process there. And if you accidentally created a small rendering, you can tell because when you zoom in, let me download it first. Because when you zoom in, it's popping up on my other screen here. Because when you zoom in, it's going to be pixelated. But if you zoom in on a 4000 by 4000 pixel rendering that we just did, it will not be pixelated. So let me pull up to my downloads. For today, I did some yesterday. For today, here is the rendering we did without the wall. And as you can see, we're zooming in and it's still holding that quality until we zoom in a little bit more, and then it might start to get blurry. There we go. Now it's blurry. But maybe about right there, we are just passing the what works, because I don't know if you can see from here, but there are bitmap textures on this one right there, which is really nice. So this, just imagine this being something on like a poster board that's 2 foot by 2 foot that you can hang up, or if it's on a website, it should be fine with just filling up the whole screen like this and still be pretty clean, realistic looking of a model. And then let's see about the other ones. They are done here. Let's take a look at the one with the walls. We'll download that, and then we'll download the other one, and we will call it a wrap. So download that one. I could have added maybe some more fun or texture to the walls. And then we'll download this one. And this one looks, maybe if this looks more like a submarine or something going on in the background there, but you can go ahead and download that one as well. And just want to show you the end results of outsourcing these to the cloud. And yeah, that took 5 minutes maybe for each of these at multiple at the same time too. So usually these would take hours locally on a machine. So just keep that in mind when seeing these results. Renderings aren't as quick as I'm showing here. Here's the one with the walls. So yeah, you can see some details there, especially with all these components here in the background. Just look at how Fusion was able to calculate the ray tracing there. And then lastly, we have our buffer skid on the docks here. I only got 2 of these tanks here, just so I can show some of the background as well. It's always nice to contrast it with a blurred out background, partially blurred out, because it's kind of like portrait mode in a sense. All right, so that concludes it. Here's just some other renderings I took. There's a similar one without changing the color scheme or the appearance. But that's all I had for us today. This will be uploaded to our YouTube channel, so definitely check that out. And next month, we'll be on editing meshes. We'll be diving into meshes again. We'll be getting meshy, if you will. Sorry to leave you with that pun there, but that's what we'll be doing next month. So I'll stay around for another 20, 30 seconds or so. If I see a question, I'll stay around longer. But thank you all for joining. I appreciate everyone's time. I don't see any questions currently, but yeah, if you are using Fusion for importing large assemblies or large renderings, I hope this was helpful to you, or I hope this was just helpful knowledge in general, regardless of your conundrum. So yeah, I don't see any questions coming in. So again, appreciate everyone's time, and I will see you at the next webinar. Thanks again.